Okay, so for this next experiment or demonstration, we're going to look at the time domain transmission, TDT measurements. Now, TDT, remember, requires an outside pulsar. Remember, the inside of a STEPScope has a pulsar and a sampler, but this pulsar cannot be used when doing TDT. Instead, you were going to use this analyzer's sampler to look at the waveform, but you need an outside pulsar so that it can then go through the device under test on its way to the sampler. So that's the setup we're going to be able to use here. Now, to do that, we need an outside sampler, and we could use either another STEPScope, or in this case, I'm going to introduce the new the remote pulsar, and we're going to go ahead and use that. So let's go ahead and look at this down here under my pulsar feature. That's where we're going to make this setting. The first thing I have to do to use remote pulsar is actually connect it to the back of the STEPScope. So by connecting that in there, you'll notice down below here I got the new user interface. It recognized it, and it gives you this new feature, this new capability. And that new capability requires that I connect the trigger signal between the two instruments. That's how it gets its synchronization. And I'm going to just do a single-ended measurement. So I'm going to take one output from the device, and I'll pulse from the remote pulsar into the device under test. Before I set that up, I need to go into the pulsar setting here and tell it that I will be doing, instead of local, where I'm the local pulsar, I'm going to use the accessory pulsar. And in fact, you can go look at the accessory pulsar. It gives you a user interface for it. For example, I can turn on or off outputs. Right now I'm driving it differentially. I'm only using one of the legs, so I could actually turn off one of those. And so now my pulsar is set up and it is pulsing. Maybe to check that, we'll go ahead and look at in the step response view. Let me use one of the through circuits that come with the termination kit, and I'm going to take the output of the pulsar and wire it straight into the input of the STEPScope. That is what we would call a through measurement. So I've got that connected, and I will go to my pulsar here, and I will have it look at the incoming wave. Here's my nice square wave that I'm getting from my pulsar, and that's if I left this run, you can see that what was perfectly square inside the instrument gets a little bit slowed down because of the cables and connectors we're using here, but this is still an excellent stimulus to go through a DUT and make a measurement. So now that I have this through setup, let me jump over to the TDT view here. This TDT view requires that I come in here and do a calibration. So I will first calibrate the through waveform. Let me come in here and say OK. And it will learn this waveform at the highest resolution that it can measure. That allows you later to pan and zoom all you want, and not requiring another through calibration be captured. Once it has this waveform, it will display it on the screen as the captured waveform. It's shown as, actually there's two waveforms here. One, the red, is underneath the green. There's a through waveform and a DUT waveform. So now for the actual measurement, I need to replace the through with the device under test. And so for this device under test, I'm going to use a small test printed circuit board. This is a demo trace. PCB manufacturers might generate such a trace for routine monitoring of a process. And I'm just going to go in one leg and out the other so that I'm transmitting along this short PCB trace embedded inside this material. Again, this is a single-ended measurement that I'm doing here. So now if I run another single trace, I can see that I have both the through waveform and the DUT waveform. Hard to see a difference. Let's zoom in on that a little bit in more detail so I can first make it a little bit larger. You can see that the green is a little slower than the red. Let's go ahead and zoom in by making this mark here. As I let go, it'll redistribute and remeasure. So it'll go ahead and remeasure that. And so, yes, I can see that I have a very slight degradation in the signal. This is a short trace, high quality cables, so that I can measure this. I have the option during this measurement to look at this with alignment between the two edges so that I can compare them. But I also have the ability to don't line up the reference edges, in which case I can see the delay between the two times. Here's when I might turn on my cursors and be able to see the time between those two devices. So that was 285 picoseconds of added delay between those two traces. Again, like all our plots, I have the download capability here. This gives me a CSV file where I can look at this in great detail and export this or import this into anything else I might want to do with this analysis. So that's a quick little introduction into the TDT using a remote pulsar.